Okay, last question. Very similar to the last question on the last paper we did. You're looking at quadratics. You're trying to solve, which is all about your roots on here. We're looking at factorizing and solving. That's what this is all about. So find an expression for the area of the triangle. Now we should know that a triangle is a half times the base times the height. You should know that. Okay, you'll have to remember that. So if that's the case, then my expression is going to be a half multiplied by 3 multiplied by x plus 12. So that means a half times 3 would just be 3 halves x plus 12. Could multiply the bracket out, but I don't think there's any point. So a half times base times height. Next question. Given the area of a triangle is equal to the rectangle, find x. Okay, so that triangle area is apparently equal to the area of the rectangle. So the area of the rectangle is breadth times height, or base times height, whatever you want to call it. So it's going to be 48 take away 6x. So that's my triangle, and that's my rectangle. And the question is saying that they are equal to each other. So my next line will just be 3 over 2 x plus 12 has to be equal to 48 take away 6x. If it had said the area of the rectangle was double this area, well, I'd say, well, that is then equal to this times 2. Or, sorry, this times 2 is equal to that, So watch out for the way it's worded, but they're just equal to each other. So how do we solve that? Well, I think the first thing I will do is times everything by 2. If I times everything by 2, sorry about all these colours, by the way, it'll make life a lot easier. So 48 times 2, so that's 96, take away 12x. Then I can break out my bracket. And just to solve, all we want to do is get x's on one side, so that's going to give me 15x, and numbers on the other, that'll give me 60. So x is going to be equal to 4. Looks like a horrible question, and for all the marks you're getting, it's pretty awesome. But yeah, the only way they can make this tricky is if you get to a point where it's a quadratic, so you might end up with like x squared, take away 5x, plus 6 or something like that, and you're going to have to solve. So I'll change that just so it's a nicer number. I'll say yeah, something like that. So add to give you this, multiply to give you that. So you might say, okay, that's going to have to be x take away 6 and x plus 1. So then x is 6 and x is negative 1. And then you would disregard the negative 1 because that doesn't make any sense because you couldn't have a negative length. That can sometimes happen. So watch out. This is a nice one. It's just a linear function. But if you've got your quadratic, the way you're going to solve it is have it equal to 0 and factorize it and work out your roots and possibly disregard a root. Okay? So just have that in the back of your head. But yeah, that's the end of that paper. So I don't think that was too bad. Certainly this one, I hope you look at that and you're not going to be scared of them when they pop up, even though it's at the end of the paper. Sketching graphs, we talked about the roots is what you factorize for. And your intercept and your turning point are just intercept and turning point, you're just substituting in your value of x, and when x is 0. We talked a bit about surds. So our surd rules and our fraction rules apply for algebraic fractions. We looked at our powers, so multiply them, and then we're adding them. We talked about reverse the change. The cosine rule is used when we've got 3 sides in the question. This is just the height of our function from the middle, so it's the full distance here divided by 2, and that's how many in 360. Here was 45, so how many in 360. Rearranging BODMAS in reverse, but watch out for those hidden brackets. Completing the square, divide this middle number by 2, and then you're saying, right, I've got 4 squared. How do I get from 4 squared to 15? I need to take away 1. PGE, whenever you've got your equation of a straight line, point gradient equation, just take your time. We talked about our different rules for the angles, where you've got your tangent rule, you've got your 90-degree semicircle rule, and you've got your isosceles rule. So if your isosceles triangle, that's a radius, that's a radius. These two angles will be the same. So 180, take away this, divide by 2. That's a good rule to know. We talk about multiplying decimals together, just taking your time with them. The number of decimals in the question will be the same as the number of decimals in the answer if you're multiplying like that. But for this one, I just kind of did it bit by bit, so we don't even have to really worry too much about the decimals. And for this, substituting in the number it wants -3 in. Sometimes it might say, f of a is 6, so you have to put in a and then work back to work out what that is. And your fractions, you've got your smile and a cross for your adding and subtracting fractions. And don't forget, this means 2/3 multiplied by what's inside the bracket, and you'll have to do inside the bracket first before you do the multiplication. So we went through quite a lot there. I hope that's helpful. Don't forget your formula sheet is here. We used the cosine rule and the volume of a cone. So we just used two of our formulas. So not as many as for the calculator paper for obvious reasons. Quite a lot of these are quite complex, So yeah, not a bad little paper. I hope that gives you some food for thought for topics you want to go over. And yeah, I'll crack on with the next paper in my next video.